Okay, good morning, guys. Just want to make sure, can you guys hear me? Okay, don't mind my voice. It's just a little bit harsh for whatever reason this morning. Let me share my screen and then we'll start. Okay, so let's start with the land acknowledgements. We acknowledge we are hosted on the lands of the Mississauga of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize enduring presence of all First Nation, Métis, and Inuit people. Okay, so today is Wednesday, August 7, day 5. So today is the day that, for when you guys are going to be doing the Unit 1 test, okay? Unit 1 test is available. It's 3 parts. There's an application part, thinking part, communication part. It was released at 12:01 a.m. This morning, and it closes at 11:59 p.m. Today. Okay, I think some people might have started it because I got some emails, but I haven't looked at it. So some people have already started. So now we're going into Unit 2. So we're going to do Unit 2 lesson today. And with Unit 2, we're going to talk about quadratics and transformations. That's Unit 2, extreme values, transformation, translations, completing the square, transformations of stretches and compression. Then you're gonna have like worksheets related to that. And then there's a quiz related to this, okay? So there's 2 things that I need today, okay? I want you guys to hear this. There's 2 things I need today. One thing is I need you to do this Unit 1 test, okay? You can do it maybe after you start, you do this quiz, because the quiz I also need today. This quiz, quiz number 1 for Unit 2, okay? I need that one today. So in order, what I would do is after this lesson, I would maybe look at some worksheets and then do this quiz and get it out of the way, right? As soon as possible. It's like, I think I have a few questions, right? So the quiz is about, 3, 4 questions. And then I would, is people still trying to wait to get in? What's going on? Okay, people are coming in late and they're missing what I'm saying. That's why I gotta watch the video. Okay. Some people are saying the test is unavailable. Okay. So that is why I'm gonna double check that right now. The test should be available. So there's a quiz for Unit 2, and then there's a test 3 parts for Unit 1. Okay. So let me look at this uh, from you guys' point of view and see about the test. So I'm going to change to student view. Okay. So the test is also under assignments. Okay. So if I go under assignments, I can see, oh, you don't see the test. Okay. So what I'm going to do now is go back. I'm surprised, but things happen. And I'm going to go in as the teacher. And I probably didn't have it so you guys can see it. Yeah, that's why. You guys can't see it. There you go. So make it visible for users. So my fault for some of you guys that are eager to do it. But now it's available right now. Okay. Sorry about that. So now I'm going to go in as a student. So I want to make sure I can see it. So when I again, I can go a couple ways. I can go to assignments to go get it, or I can click on these links. These links should take you there. So I clicked on application. It should take you to application. Let's see. There you go. Okay, so that one works, right? And let me click on the thinking one. Takes me to the thinking. Okay. Okay. And you got to read the instructions there. It tells you the instructions. And then the communication. Okay. So these are instructions which you got to follow. Okay. Full solutions required if you want to get full marks. Okay. You want to, you can print it out. You can print out, you can, open it up and print it out. Right. That's it here. And write on it. Or somehow if you want to print it out, not print it out, but have it on your tablet and write on it, that's another way. Okay. Or if you can't print, you don't have access to print, and you don't have access to writing on a tablet to write on the screen, you can just look at the question on the screen and write out the question, like it says there, write out the solutions clearly. Write out the solutions clearly, like number one, question number one, write on a piece of paper, number one, write it out clearly, okay? And then you're gonna submit it, everything on a PDF. So if you scan it into one PDF, because you only submit one thing, right? Scan it and submit all the pages in one PDF, okay? If you're taking pictures of all your solutions, because that's how you did it, you can paste it all on a Google Doc, one at a time, and then download the Google Doc as a PDF and submit it. I do not want, it says right here, do not email me solutions. Don't say it's in my email. I said email it to you because I have like 50 kids here and 50 kids are emailing me a part one, a part two, a part three. No, that doesn't work that way. And I'm saying it like 3 or 4 times. No emails of solutions. You submit it here, okay? If someone emails it to me, I'm gonna reply to you saying submit it. Otherwise, you get 0. I'm not trying to say I want to give you 0. I want you to understand that if you email it to me, you're setting yourself up for failure. Okay? You need to follow the instructions and send it through this Dropbox. Now, I want people to let me know in the chat if they understand what I just said. It's important. Let me know in the chat if you understand. Yes, one PDF, right? Each one is a PDF, okay? So you submit one PDF for communication, one PDF for application, one PDF for thinking, okay? Do you get that? Malika, do you get what I said? Do you have a question? Do you get that? Okay, one PDF for each of them. Communication, one PDF. Application, one PDF. Thinking, one PDF. You may have multiple pages in the PDF, but PDF is still one file, even though you have multiple pages, or maybe you have like multiple pictures of your solutions on one PDF with multiple pages. Okay, so please do not email. It's you're setting yourself up for failure because it becomes a calamity. Too many emails of messed solutions here, and they're not even labeled sometimes. Don't do that. Okay. So I know I said that enough times that everyone understands that now, okay? So let's get into the lesson for today. Before that, I want to just double check that the quiz for today works. The quiz for today, does it work? Yes, it does. The quiz for today works. Okay, good. The quiz would be for Unit 2, and we're going to start Unit 2. You know, you're not understanding that question. Okay, that's not what I said. I didn't say one PDF per page. That's not what I'm saying. One PDF. I'm going to go here. You see how you have an application, you have a thinking, you have a communication. You're going to submit one PDF for this, one PDF for that, one PDF for that. Do you get that? I wish. Do you get? Okay, yeah. So in a PDF, you can have 5 pages, right? Is that true? Right? Most likely, with these questions, I'm just going back on memory. I think these questions are, if you were to write it on the actual paper, I think it's like 1 page. But some people may not able to write on the paper. They may have to write out the question on their own piece of paper. If it takes you 2 pages to answer all the questions for application 1 for this application, if it takes you 3 pages of writing, like 3 pieces of paper, you can scan that paper, all those pages, into 1 PDF, okay? And then submit it for the application. Make sense now, Arash? The time limit is you have all day. That's the time limit. Does that make sense now? You have all day. You're going to open it up. You have all day. Okay? Well, you don't have all day. I mean, you have until 11:59 p.m. Okay? Okay. So I hope you guys understand that. I want to do this at the beginning of the video. This is all being recorded because if some people are not here, they're going to watch it, and I want them to hear this at the beginning versus at the end. Okay? So let's get into what we're doing for today. Go into content. Okay. So now let me go into view as a student again. Are there 3 pages total? I remember for the application, I don't want to just show you the test, but for the application part, it could be 1 page or 2 pages. I don't know. I didn't open it up because I didn't work on making this test, right? But from my memory, it is 1 page, maybe it's 2 pages. But the other thing I'm trying to say for Saban, some people may not be writing it on the actual test. Some people be writing it on a piece of paper. Okay. And if someone takes 3 pieces of paper to finish the application, like this one paper, maybe there's 5 questions, okay, on application. So I do 3 questions on this paper. I do 2 questions on this paper, okay? So now you're gonna have to scan the papers together to make 1 file PDF. Does that make sense, Saban? Does that make sense, Saban? You're asking that question. You're not responding, so I don't know if it makes sense to you. Okay, so let's go to Unit 2. Okay, August 7th. So let's get into it now. I'm going to come back to you, Saban. Okay. Oh, so you understand it? Is that what you're saying? Okay, thank you. Okay, thank you means you understand what I said. If you don't understand what I said, let me know. Say yes, I understand, or no, I don't understand. Okay. So here we are. We're going to talk about things for August 7th. Oh, it's too much. I'm just looking at August 7th. So things for August 7th is min and max. Okay, let's get into that. Okay, so we're talking quote min and max for quadratics. So there's two videos here. And then there's a worksheet there. And then there's another lesson, which is we're talking about transformations. There's a video there. We're going to go to that. And then there's questions. And then, oh no, that's not for today. That's tomorrow. Okay. So August 7th is today. So let's look at what we're going to look at today. So min and max, we should know what that is. Let's get into that.
Here's just a quick lesson on completing the square.
Okay, so let me increase the volume. In order to, because the whole point of what we're doing here, completing the square, and completing the square, I think was in grade 10, right? You guys remember that in grade 10? I want to know if you guys remember that from grade 10. Some of you guys? Okay. Okay, so it comes back because we need to figure out what's the min and max for a quadratic, right? So usually what happens is you're giving it, it's given to you in standard form, and we want to go from standard form to vector form, okay? Vertex form, I meant to say. And then with the vertex form, then you'll have your H and your K. And your H and K give you your vertex. So if I'm graphing this parabola, the vertex is the one at the right where it changes from directions, coming down, then it starts going up. Okay. So this is your vertex, right? And this here, for this one here, that would be a min. And then this one here would be a max. Okay. I'm not drawing this correctly. Okay, a max. So we'll get into that. But in order to do that, you have to learn you have to do the process of from here to here, you have to do the process of completing the square. Okay. And then if you look at this here, right, this is basically like a perfect square or a difference of square. Okay. So we're going to get into that right now. That's what we're getting into. And then from there, we're going to look at the transformation translations of this. So let's continue.
So this is just designed to be a refresher lesson, reminding you of the method of completing the square. So completing the square is a method that helps you turn a quadratic that is given to you in standard form and changing it into vertex form. Now I've done a more in-depth lesson on this in the past, so if you want a more detailed explanation of why I'm doing the steps that I'm doing, look at one of the previous lessons I posted on completing the square. This is just designed as a quick refresher on the steps to complete the square. The reason why we want to change a quadratic from standard form to vertex form is so that we can quickly pull out the vertex of the quadratic. The vertex of a quadratic that's given to you in vertex form is HK. So if we have it in vertex form, we can pull out the vertex HK, state whether it's a max or a min. If A is positive, it's a min. If A is negative, it's a max. Because if it's negative, it opens down. If it's positive, it opens up.
I used to spend dozens of hours every single week.
Okay, I'm just going to mute the commercials as we get through them.
In the previous, I won't explain too much, but basically, to get from standard form to vertex form, the key thing we're going to need to do is create this right here. This is a binomial.
Okay, so that's basically what I was saying before. So let's just fast forward into where we do an example. Okay. So these are the steps to completing the square, right? So the first step is to put a bracket around the first two terms. And then when you do that, you may have to factor something that's with the x squared. Okay. And then you look at the last term in the bracket, and what you do is divide it by 2 and then you square it. Okay. So then when you do that, you add and subtract that term behind the last term in the bracket. Okay. Okay. So then you move the negative term outside, and then you simplify, and then you perform the perfect square trinomial. Okay, so we have to go through an example, but that's the step right there. So here's the example, right? Right. Remember when we say y, right? When we say y is the same thing as saying f of x, okay? Okay, we mean that's the same thing. But because we're doing just completing the square, but we know that's going to be the answer. I mean, it's going to look like that's the notation, okay? But for now, we're just going to use it as y because we're just doing completing the square. Okay, so the first thing you do when it says complete the square, right? You want to write it in vertex form, right? We know vertex form, and I think he's trying to show you that off to the side. So let me just fast forward that so you can see the vertex form. Okay, so that's what we're trying to get, right? The vertex form is that. So what we're gonna do, like the first step, put a bracket around the first two terms. So these are the first two terms. Put a bracket around it. Okay. And then what does it say? We're going to take the last term, this term, divide it by 2 and square it. So that number 8, we're going to divide it by 2 and square it. So it's going to then be divided by 2 gives you 4. 4 times 4, because we're squaring it, is 16. So it's plus 16. And then we have a minus 16. Close bracket, plus 5. So what we did there was we're basically are cheating the system by adding a 0. It's like 16 minus 16 is still 0, right? If I add 0 to this, the equation didn't change, right? Because 0 is nothing. But this is a fancy way of adding 0 to this equation, so you can rewrite the equation as a vertex form, okay? Plus 16 minus 16 is still 0, right? So we didn't really change the equation, the value of the equation. We're just now changing the way it's written so we can get it into vertex form, okay? So now what we want to do is take this negative 16, take it outside the bracket. If there was a number here, we would have to take that negative 16 and multiply by the number over here, but there's no number there, okay? So we rewrite it, and it's going to be x squared plus 8x plus 16, then minus 16 plus 5. Then we can simplify, right? So if we simplify, on the outside, we're going to have what? Minus 11, okay? And then when you look at this, this here is a perfect square. Two terms that give me multiply give me 16, and then two numbers when I add them together give me 8. Well, that's 4, right? 4 and 4. Okay, so I can write this as x plus 4 bracket x plus 4. I can do that. But that's just like basically saying this, x plus 4 squared. So that's what I'm going to write. That's basically what I need, right? So y is going to equal to x bracket x plus 4 squared minus 11. That is my vertex form now. So my vertex is made of h and k, and basically my h is actually -4, okay? Because here I have a plus 4. If you look at the equation over here, the equation is made up of, it shows a negative in there. So if I plug in 4 here, so in order to get this negative, I would have to have a -4 here, okay? In order to get this plus over here. So -4, when I plug it into here for h, gives me a plus for this equation. So my h is -4 and my k is -11. So that'll be my vertex, okay? So if I were to plot at this, that point there would be -4 and -11, okay? So I kind of went through what he's gonna go through, so so we know the final equation. I'm going to play the video and then you'll see the final equation the final vertex form should look like this, okay? So let us continue.
We get this binomial squared so that we can easily pull out our vertex hk. Step 1, you put the first two terms in brackets, and you leave your c value, our plus 5, off at the end outside the brackets. Next is we need to then, so you notice it already starts to look like vertex form a little bit more, but we need to create a perfect square trinomial inside these brackets so that when we factor it, we get the binomial squared. Here's the trick for creating the perfect square trinomial. We're going to add 0 in a fancy way. What we're going to do is inside the brackets, we are going to add and subtract half of that 8 squared. So you take half of 8, square it, half of 8 is 4, 4 squared is 16. So what we're going to do is add and subtract 16 inside the brackets. I'll continue in red. So we keep our x squared plus 8x, and I'm going to add 16 and subtract 16 inside the brackets after it, and keep that plus 5 off at the end. So I've added 16 minus 16, that's 0. So I've added 0 in a fancy way. What I have inside the brackets here is a perfect square trinomial, and then this annoying minus 16. I need to take that minus 16 outside the brackets by multiplying it by the value in front of the brackets, which in this case is just a 1. So 1 times negative 16 is negative 16. So outside the brackets, it's going to look exactly the same as it did in the brackets. So I take that negative 16 outside the brackets, and my last step is going to be factoring this perfect square trinomial that I've created. And it's going to factor very nicely to a binomial squared if I've done things properly. I need to find two numbers. So when factoring a quadratic with an a value of 1, you find two numbers that have a product of your c value, a product of 16, and a sum of 8. The two numbers that multiply to 16 add to 8 are 4 and 4. And that should always happen when you factor a perfect square trinomial, is you get the same number here and here. It's a number repeated that gives us our sum and product of what we're looking for. So when I put it into its factors, it would be, I'll erase this in a second, it would be y equals x plus 4 times x plus 4, with the negative 16 plus 5 off at the end. I'm not going to write it as x plus 4 times x plus 4. Anything times itself, I could write that as x plus 4 squared. And then negative 16 plus 5 is negative 11. So it's now in vertex form. My vertex actually asks us for axis of symmetry as well. I'll write that first. Axis of symmetry, that's the vertical line that passes through the vertex. It's always x equals whatever the h value is. In this case, h is negative 4. Our vertex.
Tell me you're a runner.
Okay, I'm just gonna mute that. Okay, I'm gonna mute that. Okay, let's skip. Oops.
And in this case, our h is -4, our k is -11, so the vertex is at -4, -11. Is the vertex a max or a min point? Since our a value is +1, that means the parabola opens up, which means the vertex is at the bottom of the parabola.
Okay, so we get that, right? So we should know how to do that because that's something we've done in grade 10. Okay. If there's another example, the only difference with this example here is the fact is you have a 2 in front, the x squared, and you have to factor out that 2. Okay. Because you have to have x squared by itself. So if I factor out that 2, first of all, the very first step is to put a bracket around the first two terms. So I'm going to fast forward this so we can see the steps and look at this one a little faster. Okay, so there you go. Put a bracket around the first two terms, as you can see there. Okay. And then I'm going to factor out that 2 in front of the x squared. So I'm going to be left with 2 bracket x squared, and this is going to be -6x, right? And then you have a bracket plus 11. Okay. Fast forwarding, looks like that. Now, what we do is that -6x, we divide it by 2, and then we square it. So 6 divided by 2 is 3, okay? And then when we square it, it equals to 9. So I'm gonna have a +9, and then I put a -9. That's another fancy way of adding 0. So +9, -9, okay? That's what's gonna be there. Okay, there you go, right? And then plus 11. So the next thing is I want to take out that -9 outside. I want to take it out. But for me to take it out, as I take it out, that -9, I have to multiply the number that's in front of the bracket. So I have a 2 now this time. So -9 comes out, and times 2 becomes -18. So it's going to be 11 minus 18 outside the bracket. Okay. Okay. So now what I want to do now is simplify things. So this -18 plus 11 becomes -7. And then I look at this here, x squared minus 6x plus 9, two numbers that add up together give you -6. And the same two numbers, when you multiply together, gives you +9, is going to be -3, right? So -3 minus 3, okay, is going to be the answer there. So now I'm going to have, I write my bracket. My bracket's going to be 2 bracket x minus 3 squared. Okay. There you go. And then I have -7. So the vertex now for this is going to be, it's going to be, use blue for this. It's going to be, my h is, I didn't mean to use blue, sorry. I meant to use blue. My h is going to be that. My k is going to be that. Okay. My axis of symmetry is the value of my k. Sorry, my axis of symmetry is the value of my x of my vertex. So let's fast forward a little bit. That's what's going to ask you now. Oops, let me close that. Okay, my axis of symmetry is my h value. My h value is 3. And my vertex is 3 and -7. Okay. And then the question is it a max or min? Well, it's a min because the number in front of here is a positive. So when you draw it, it's going to be like this. So it's a min. Okay. So the next part, let's see. There you go. It's a min. Okay.
Let's move on to this one since it has a fraction.
So this is where you may get a tricky one like with a fraction. You guys don't like fractions, but you have to deal with fractions. Okay, so I won't really go through this. You can watch the video because I think I have to go through some other things as well, like the transformation. So, you know what? I'll go through this. I'll step it through. Okay, but even though it's fractions, there's nothing different. It's the same process. People see fractions and they get scared. Same process. I'm gonna put a bracket around the first two terms. Okay, so that's what he's gonna do here. Put a bracket around the first two terms. Okay. So then you see the number in front of the x squared, I have to take it out. I have to factor it out. So if I have to factor out, what that means is I'm going to divide each of these terms by negative 2/3. So 2/3 is going to be out in the front. Over here, it's going to be 8 divided by 2/3, which then basically means 8 times 3/2. So I'm going to fast forward that so you can see that. Okay. It's showing you there. 8 divided by 2/3. You see that up there? But then it's like basically you multiply the reciprocal. If you know fractions, when you divide by a fraction, you multiply it by the reciprocal, right? So it's going to be 8 times 3/2. And the answer you get there is the number you're going to put over here, okay? And what is that? That is, I guess, negative 12, okay? So that's what you're going to put over there. But you see the fraction, you got scared. Oh my God, I don't know what to do. It's a fraction. It's not really, you don't change the process. It's the same process, okay? So from there, it looks like it gets easier because I have a nice number of 12x, okay? Then you're gonna do the same thing where two numbers, sorry, we get to the second term, divided by 2 and you square it. So negative 12 divided by 2 is negative 6. Negative 6 times negative 6 gives you plus 36, okay? So you're gonna add 36, then you're gonna subtract 36, which is like a fancy way of adding 0, okay? There you go. Then now you do the simplify where I need to take out that negative 36, take it outside the bracket. Before I take it out, if I take out that negative 36 out, I have to multiply by negative 2/3. So when I turn that negative 6 outside, it's going to be negative 36 times 2/3. Okay. And then comes outside. So what's it look like? So negative 36 times 2/3, right? Gives you plus 24, okay? So now I'm gonna simplify, give myself some space. So two numbers here would be, to give me this bracket, two numbers that give me negative 12 and then also give me 36 would be 6, right? So x minus 6 squared would be in my bracket. Okay, there you go. And then 24 and 5 gives you plus 29. Okay, so my axis of symmetry is my h value, which is going to be my 6, and my vertex is going to be 6 and 29. Okay, now the question is it a max or a min? Well, no, it's a max because I have a negative number here. So that becomes, that tells me it's going to be a max. Okay, so it's a max. There you go. It looks like a parabola looking like that. Therefore, it's a max. Okay, so we're done with that video. Let's see here. Give me a second. There's a few things we have to still cover. So this may be a little bit of a longer session because I talked about the test a lot. So let's see this video here. We talk about max and min. Let's look at this video. I think this is video 2. So let's look what's the video 2 about.
Okay, here's another part to the 1.3 finding the max or min of a quadratic lesson.
Yeah, I'm going to cancel that. because it's another method, which I don't want to confuse you guys. The factory method is, you can look at that video if you want to, but the completing the square video is probably the video that you need to know more. So that's why I don't want to waste time with that. So this video one talks about completing the square in order to go from vertex, standard form to vertex form, which you guys should know this from grade 10, right? It's just a refresher. Okay. If we were to look at the document, this is the document here. Okay. Which is basically, this is basically showing what we saw in the video. So let's look at that. Okay. Okay, so basically it's showing you to get this to factored form. Okay. Completing the square. Okay, so some of the stuff we watched in the videos in here, so you can go through this this lesson. Okay. Let's go back to the other video for today, and here's the worksheet. So this worksheet would basically be talking about, let's look at it. Again, this is just practice. It does not count for marks. So please don't keep asking me, does the worksheet count for marks? It doesn't count for marks. Okay. Oh shoot, I have to do all this. Okay. I'll go this way just to show you. Doesn't count for marks. Okay. Just remember that. So basically, stay at the vertex, what's the max min? So this is what you, and see how it's written in f of x? It's written in f of x, not y. Okay. So that's what you're doing. These questions here for that. Okay. And then this will help you for the quiz. You don't have to do all of them. If you understand it, then if you're ready to do the quiz, you can do the quiz. Okay. Okay, so let's go back to the content. We're going to look at now introduction to transformation. Okay, so we'll look at the video for transformation.
Are you tired of your hair breaking after waiting years?
We're gonna pause or mute the commercial. Making sure it. Give me a second, guys. Oops, this is not. Might have clicked on something else accidentally. Let's go back. Okay. Gotta make sure it's. I'm just trying to maximize the screen, guys. Give me a second. Okay.
See what transformations happen when we apply different parameters.
Okay, let me go back to the beginning.
Transformations of functions. We're going to look at a few different functions and transformations of those functions this unit. First function, we're going to look at the function f of x equals x squared, so a basic quadratic function. We'll apply different parameters to that.
Okay, so in grade 11, we don't just always just look at quadratics. I know grade 10 we looked at quadratics, but we're going to look at other types of functions and the way they look. Okay, so the first one we look at is always been quadratic. Then we're going to look at the next one. Sorry, my bad. This is a radical, okay, function. And this one here is a rational function, okay? So these three are the ones that we tend to look at in grade 11. This is grade 10 though, but these other two are the new ones you guys are gonna look at. And then we're gonna look at it for the transformation and for the translation. And if you remember in grade 10, when we talk about translation, transformation, that means we're saying, is the graph, vertical compression or vertical tension, horizontal tension, horizontal stretch, I meant to say vertical stretch, or horizontal compression. And then did it move to the right, to the left? Did it move up and down? Okay, and that's going to be for each of these, not just for the quadratic. Okay, so let's get at it.
The equations of those parent functions. So first of all, when I'm saying transformation, what does that mean? So basically a transformation means we're
Okay, let me just go back to the beginning so you can hear what those functions are. Okay.
Transformations happen when we apply different parameters to that. We'll also look at the function root x, and we'll also look at the rational function 1 over x. So we'll work with those three, we'll call those parent functions, and we'll look at how we can transform the graphs of those functions by applying different parameters. We'll call them a, k, d, and c to the equations of those parent functions. So first of all, when I'm saying transformation, what does that mean? So basically a transformation means we're either going to be shifting the function, so shifting the graph of the function either left, right, up, or down, or we're going to actually be changing the shape of the function by doing what's called vertical or horizontal stretches or compressions, or also vertical and horizontal reflections. And how we're going to do that is by looking at the parent function f of x, so like these were different parent functions we're going to work with, and we're going to apply different parameters to those parent functions. We're going to apply the parameters a, k, d, and c.
Okay, so the parent function, so this here, f of x, is always considered a parent function, okay? And then we write it as whatever, if it's x squared, that's the parent function, or another parent function we saw was, root x, right? Or another parent function we saw was 1 over x, the rational, okay? What happens is we apply a or a k or a d or a c to these functions, and it will cause it to transform or change shape or move, and it results in g of x, okay? So that's what we're doing. We're taking the parent function, and then we're going to transform it into the whatever it tells us to do based on the transformation, okay?
And this is the general form of the equation of a transformed function. So g at x would be the equation of a transformed version of the function f at x. We'll call f at x the parent function, and we'll call g at x the transformed function. So g at x is equal to some transformed version of the parent function f at x. But what we've done to f at x is we have applied the parameters a, k, d, and c to move the graph of the function f at x, to stretch it, to compress it, shift it left, right, up, and down, or reflect it. So let's just quickly look at, before we get into these functions, x squared root x 1 over x, let's just quickly look at, before I explain what a, k, d, and c do exactly, we're going to quickly look at just a basic function like this. And we'll do transformations to that before we actually look at quadratics, radical, and rational functions. So I mentioned a, k, d, and c.
Okay, I'm going to pause.
So I will send you pictures.
So here's the equation of our transformed function g at x. It's equal to a times f at x with k, d, and a c in here as well. And what we're going to do is we're going to look at what exactly do these a, k, d, and c parameters do to the parent function f at x. So we'll go one at a time. We'll look at the vertical transformations first. So the vertical transformations are going to be a and c. And then the horizontal transformations are going to be caused by the k and d parameters. So let's look at a and c first. So c, that's just going to shift the function up or down. If c is a positive number, so if it's greater than 0, it'll go up. If it's a negative number, so if c is less than 0, it'll shift it down. A is going to vertically stretch
Okay, so I want to see if I can fast forward some of this, because some of this you should know. A, when that's in front of the your function, either stretches it or compresses it, okay? Vertically, okay? And also if it's a negative, it does a vertical, sorry, a horizontal reflection. I meant to say vertical reflection, okay? So we can fast forward that. I think we need to get to examples to actually guys to see that, but that's what A does. Okay. Let's fast forward. So D, that's inside the bracket, it shifts it either to the left or to the right. Okay. We know this from when we're doing when we're going from from standard form to vertex form, right? Instead of D, we had H back then, right? So D is the same thing, it just transforms it left or right. Okay. It moves it left or right, I should say. Translation just means moves it left or right. And then we have K, which is in front of, let me fast forward it a little bit. This is just telling you here, if you have a +5 there, that's actually a -5, because that's the only way this equation will work. Just like when we saw when we were talking about the H in the other transformation for quadratics only. Okay, let's get into the K. So K, now if there's a K in front of your X, like right in front of your X, that either stretches it or compresses it. So how you know that is the K value, and I'm gonna have to write this. If I have here, I don't know, my G of X equals to F of bracket 1/6X. What that means is my K, my factor, on the K, my factor is going to be 1/K, right? So, but then the K here is 1/6. So that's going to be well, my K is 1/6. Okay. That equals to, if you do the math of that, 1 divided by 1/6, remember 1/6 is a fraction, right? So if I'm dividing by a fraction, I multiply the reciprocal, this turns into 6/1. 1 times 6/1 is just 6. Okay. So because of my factor is 6, it's going to be 1 over a factor of 6. That's going to be this factor, this thing here, is greater than 0. So since it's greater than 0, it's going to give me a horizontal stretch. A horizontal stretch. Okay. So what's confusing is that this value of K is my value of K. Because I put it into this factor, this value of K of 106 is actually going to give it a stretch. Okay. It's going to give you the stretch. Now, if I had a value of, if my K was, I'm going to change colors now. Say if my K was, let's do red. If my K was, if I said K was equal to 1, no, say my K was equal to 7. So now my factor is 1/K equals to 1/7. So 1/7 is basically less, it's in between, sorry, 1/7 is a fraction. And if you look at 1/7, okay, it's less than 1. So if it's less than 1, even though I said my K is 7, but then the factor is 1/7, even though it says it's K is 7, it's actually a compression, okay? Because you always have to look at it as 1/K. So that 7, it goes into 1/K, it gives it a compression. Over here, my My K is 1/6. I plug it over here. 1/1/6 is 6. Therefore, it's a stretch. Okay, so understand that. Okay, you got to practice. Hopefully, you're not bored what I just said. It took a while, but that's what happens there. Okay, I'm going to play the video so you can hear it twice. Let me play the video.
The X, what's going to happen is it's going to cause, instead of a vertical stretch or compression like A, it's going to cause a horizontal stretch or compression by a factor of 1/k. So since it's by a factor of 1/k, when k is bigger than 1 or less than -1, that's actually going to cause a horizontal compression by 1/k value. If it's between -1 and 1, it's actually going to cause a horizontal stretch by 1/k. And if it's less than 0, so if it's a negative value, it's going to cause a horizontal reflection. And when we're talking about horizontal stretches and compressions, we're talking about the points of the parent function, its distance changing by a factor of 1/k in relation to the y-axis, so moving horizontally in relation to the y-axis. In a horizontal reflection.
Okay, so let's get a look at an example, okay? So here is the order of transformations. So you're looking at, first of all, what are the stretches, compressions, and reflections? And then what is a translation? Translation moves it up and down, left and right. So the stretches are the A values, right? Or the K values. And if it's a minus, or if those A values or K values are minus. So you're gonna look at your stretches vertically, or vertical stretch or compression. Then you're gonna look at your horizontal stretch or compression, and you want to know if it's a negative. That way, if it's a negative, it would flip either a vertical reflection or horizontal reflection. Then you want to look at your translation. So your D moves it left and right, and your C moves it up and down. Okay. So let's look at this example. Okay.
Tell me you're a swimmer.
Okay, I'm just gonna wait till the video commercial's up. Okay, here we go.
To do.
Okay, so if you look at this one here, this is an easy one in a sense that it's saying f of x. So this is the translation of this. Okay, this is the parent graph, which looks like f of x. But we're saying we're gonna do a translation to it by having x plus 2. What that means is that's the x plus 2. So if you look at the equation of that, right? Here is our general translation equation, right? Here I have a minus d. The equation is a minus d. That translation that I just showed you had a plus number. Therefore, that plus number is actually going to be a minus number, okay? So this here is my d. If I have a plus 2, that means this must be a minus d. That means I'm moving to the left. So this is actually a minus 2. If I'm moving to the left, I'm moving to the left on the x-axis. Okay, there you go, shifting to the left. So this whole graph will just shift to the left. Okay, whatever value I have for x moves to the left, 2 spots. Okay, so you'll see right now how it looks like. They're plotting it. So that value went over here. This value was over here, went over here. This value was over here and went over here. This value was over here, then went over here. So just move to the left, the whole thing, okay? That's your translation. This one here, minus, this is your A, it's a minus 1. Your A is 1, so that means there's nothing, there's no stretch or compression. but it's a minus. That means it's going to be a vertical reflection. So that means my y value is going to be, if it was positive, it's going to be negative now. Okay. So negative, so if it's 2, it's going to be -2. If it's -2, it's going to be +2. Okay. That's what happens there. So when you plot it, there you go. So it reverses and looks like this. Okay. A vertical reflection over the x-axis. Let's look at another one. Okay, this one here is on the outside. So that's going to be my C value. My C value moves everything up or moves everything down. So here I have a +3, so that means it's going to move everything up. So whatever value I have for my Y, right, I'll move it up by 3. So if this is a +2 over here, it's going to go up to 5. So everything got shifted up by 3. Okay. So fast forward, there you go. So it's right there. Shift up by everything by 3. These are easy because they're all by themselves. So here's going to be a combination one. Right? You can see this is the combination one, right? I have something on my I have a K here, and I have here also a C. So with my K, right? It's a +2 for K. That means my factor is 1 over. So if my K is 2, that means the factor is 1 over 2. That means it's going to be a compression. Okay, it's going to be a compression along horizontal compression. Over here, my C is -1. That means it's going to go down -1. So when we are going to plot this, what we're looking at is my K applies to my X. So whatever my X value is, I'm going to divide it by 2. Whatever my Y value is, I'm going to take away 1. Okay, that's what's going to happen here. So I take this 3 divided by 2. Take this -1 divided by 2. Take this 1 divided by 2. Take this 3 divided by 2. These are going to be my new values for my X. And then for my Y, well, if I have a 2, I subtract 1. If I have a -3, subtract 1. Then these will be my new Ys. And then I plot it, then you're going to see how the graph looks. Okay, that's what's going to happen here. Okay, so let me kind of fast forward so you can see it. Right, so the g of x is just showing you that's the transformation function. F of x is the parent function. So this is the parent function you see here. So let's get into, so you're going to see he's going to graph, he's going to make a table. There you go. See, whatever x you have, I divide by 2, right? Because it's saying here k is 2, and then it's a horizontal compression by a factor of 1 over k, which is 1 over 2. That means I'm going to have every x value divided by 2. That's what I told you there. And every y value, I'm going to go down by 1. Okay. So he's going to show you there on the side. Every y value, subtract 1. Okay. That's what I showed you there. So let me clear the screen so it looks more clear. So you can see what's there on the screen versus what I wrote, but it's the same thing. Okay. And then you have your x and y, and then you plot it. And then when you plot it, you're going to see it shrunk a little bit, and then it moved down. So if you draw it out, there you go. See, it moved down and it shrunk a little bit. Okay.
We'll call those the points of the parent function. We get what are called the image points, which will give us the graph of the transformed function. And don't forget to label this transformed function. We've called this transformed function g at x.
Okay, so that is the lessons for today. Okay, That's it. Tomorrow we're gonna go into transformations of x squared and so on. That's, you guys can't probably see that yet until tomorrow, but you have your worksheet for this. Let's look at the worksheet together. Okay. The worksheet again, it's not, you don't need to hand this in. Please don't keep asking me that. You don't hand in the worksheets. It's just for you to practice. That's what they call practice worksheets. Does not count for marks. Okay, so let's look at that. Okay, so describe the transformation. That's gonna be done. Okay, so this is what you'll be going through. Okay. And then you can see here, the answers are right there. Okay. Okay, so hopefully that helps you to get ready for the quiz. Let me go back to the beginning. Okay. So I'm gonna close like this. Basically, you have what we talked about here, the transformation stuff, completing the square, 2 worksheets, a quiz, okay? And then you have this test, okay? The test is due 11:59 p.m. tonight, okay? So I think that is it. I hold you guys up enough. I hopefully, there's any last questions here? Anybody, if there's any last questions? Don't know what to do? Everyone's good? Put a thumbs up or say everything's good in the chat. I want to see if you guys are awake. Okay, some people are awake. Okay, everything's good. Okay, so I'm gonna stop sharing my screen. I'm gonna stop recording.